Now this is a remediation for your Topic 2 test, Part 1, Linear Functions. You are to make sure that you go through each one of these problems and these slides go match your test exactly slide for slide. You are to learn how to work these problems before you retake your test. This is Topic 2 test, Part 1, Linear Functions, Remediation. So slide number 3, you see that you're describing patterns and determining the next figure right here. You're given the following sequence and describe the pattern that you see. You see there's 1 block here, 4 blocks here, 7 here, and 10 blocks here. If you were to write out the sequence like I have it right here, and then start the back and go backwards, 10 minus 7, 7 minus 4, 4 minus 1, you see the common difference is 3 right here, because 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 more would be 13 if you had to come up with the next figure. So as you're looking at this right here, you see that on this answer it says 7 more squares. You're not adding 7 more squares, you're adding 3, so this one is automatically out. This one says 3 more squares. Yes, you are adding 3 squares to it. This one says 3 less squares, you are not subtracting 3. And this one says you have twice as many. That means you have to multiply, and you're not multiplying to get to the next term. So the answer to this is 3 more squares. Now on this one you have to find the term values. And so I have written out my blanks right here. On the first day she collected 2 cans, there's my 2. On the second day she collected 8 cans, there's my 8. And on the third day she collected 14 cans. Now, if this pattern continues for each day, how many cans will she have after 9 days? So I have drawn out 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 blanks. And then I subtracted 14 minus 8, 8 minus 2 to come up with my common difference. So you're saying 2 plus 6 is 8, 8 plus 2 is 14, 8 plus 6 is 14, 14 plus 6 is 20. Or if you have the graphing calculator, you can say this. You can enter, I'm going to turn it on, and so I'm going to clear it. I'm going to put in 2, hit enter, that's my first term, plus, and my common difference is 6. So I'm going to put plus 6 and hit enter. Enter, and as you can see, it's going through the sequence right here. The next term is 20, 26, 32, 38, 44, 50. And this right here is the 9th term. There are 50 cans. She'll have 50 cans after 9 days. Slide number 5. This one you had to identify the next point. So the first thing that we're going to have to do is subtract and to come up with our common difference right here. So I put in a negative 2.79 minus negative 1.79, and you come up with a negative 1. Then take the next two terms, negative 1.79 minus negative 0.79, and come up with the negative 1, and you're going to go all the way through the sequence to make sure that they did not put in one of these crazy sequences on you that does not give you a negative 1 all the way through. And as you can see right here, I've already subtracted it, gives you a negative 1. So this is decreasing, and you're going to be adding a negative 1 to each previous term. So I'm going, in order to come up with the next term, and this is the recursive rule, you're going to reuse the last term. You're going to find the difference and reuse the last term. So the last term is a negative 2.79, which I have right here. And then I'm going to add my common difference to it, a negative 1, and my answer that we're looking for is a negative 3.79. Slide number 6. On slide number 6, you're going to find the common difference, which has a common difference of a negative 1.46. Start, subtract going backwards. And so once you see that you do not have this common difference, stop. You do not have to continue on with the pattern or the sequence to see if it gives you a negative 1.76. Now make sure it's a negative 1.76, not a positive, because they will try to trick you. So when you're looking at this right here, you have a negative 6.84 minus the negative 4.38, and it gives you a negative 2.46. Stop. That is not what you need. You need a negative 1.46. Now, on this one right here, as you can see, this did give me a negative 1 point, and I need to put that a decimal right here. So I'm going to draw this, and it does give me a negative 1.46. So I'm going to go through and check every one of these to make sure that this right here does not give me a, make sure it all gives me a negative 1.46. And I have subtracted all the way through this. And as you can see, this is your answer that you're looking for, a negative 1.46. Now, when I check this one, it gave me a positive 1.46, and I left my decimal off right here. And so I'm going to put that gave me a positive 1.46 instead of a negative 1.46. And then when I subtracted this one right here, this one gave me a positive 1. So this answer is automatically out also. You're looking for a negative 1.46. So check to make sure that you have the correct common difference that you're looking for. They will try to trick you. Now, slide number 7, you're going to use the explicit formula. Now remember, the first term that you see right here is your first term. That's a sub 1. Here's your formula right here at the top. And then you have right here is your common difference. Now, this right here, these are the points that you're looking at. I just went ahead and put them in a T-chart or a table for you. So when I look at this right here, I started at the bottom and went backwards. 34 minus 26, 26 minus 18, and 18 minus 8. And you see my common difference is an 8. Now my first term is 10, and my common difference is 8. So I'm going to go through here and check just the first term. And I see this one right here is a possibility. This is 8, out. Negative 10, out. Negative 8, out. 18 is out. So based on just the first term right here, we were able to eliminate 4 of the 5 answers right away because this is the common difference of 10, first term of 10, and the common difference is 8, and that is what we're looking for. So look at those two things right off, and then also check this. Make sure that they did not swap the n and the 1. Sometimes they'll say 1 minus n, or they'll put a plus right here. Remember, the formula says n minus 1. That is one other thing you also have to check. Number 8, on this one you're going to be matching the following tables with the explicit formulas that they represent. Here's your formulas right here, the explicit formula, and then when you check this right here, this is what you're subtracting. 25 minus 50, 50 minus 75, 75 minus 100, 100 minus 125. And you see the common difference is a negative 25. The first term is 125. When you do the same thing for this, 148 minus 132, 132 minus 116, 116 minus 100, 100 minus 84, you get the common difference of 16. The first term is 84. On this, 140 minus 120, 120 minus 100, 100 minus 80, 80 minus 60 will give you a common difference of 20. Your first term is 60. Now look over here, and I'm going to match these up with this. My first term is 125, so I'm going to look down through here. Here's a possibility, and here's a possibility. Now, so I'm looking at this right here. My common difference is a positive 25. My common difference right here is a negative 25, and this is what we want. So this one is the one that will match this, and I have already matched it up over here for you. Now this one we're looking for, the first term is 84. So here's 84, and that is the only one with 84. So this one will go with this, and as you can see, I've already matched it up right here. And then when you're looking at this one, my first term is 60. So I'm going to check my first terms. Here's a 60. And that is the only 60 that we have. So this is the explicit formula that matches this. And I've already matched it right here. So check the first term and the common difference to see which ones match. Slide number 9. You're identifying the sequence. Which of the following sequences can be described as an arithmetic sequence. And as you're looking at this, start the back and subtract and go backwards. The common difference must be the same for it to be an arithmetic sequence. So I'm going to start at 60 minus 51 and I get 9. 51 minus 41 and I get 10. Stop. Do not go on. These two are two different common differences. It is not an arithmetic sequence. Now I'm going to start with this one. Negative 32 minus negative 26 and I get 6. Negative 26 minus negative 19, I get a negative 7. Stop. Do not go on. Now here, and I have worked this one out for you. Start the back. Negative 16 minus negative 10 is a negative 6. Negative 10 minus negative 4 is a negative 6. Negative 4 minus 2 is a negative 6. 2 minus 8 gives you a negative 6. So this one has the same common difference all the way through. So this is an arithmetic sequence. Now, when I check this one, 810 minus 270 is 540. 270 minus 90 is 180. Stop. These are not the same. This is not an arithmetic sequence. Now check this one. 7 minus 3 equals 4. 3 minus 0 is 3. This one right here does not have the same common difference. Stop. Do not continue on. Now this one, as you can see, is already marked, and that is this one. And so I'm starting at the back and subtracting. 32 minus 25 is 7. 25 minus 18 is 7. 18 minus 11 is 7. 11 minus 4 is 7. So remember, start the back of the sequence and subtract. The common difference must be the same for it to be an arithmetic sequence. You must have it all the way through. You must check it all the way through, because sometimes in the middle of the problem, they will have an odd number thrown in there to throw you off, because you'll think, oh, that's it. And it won't be. So make sure you check it all the way through. Slide number 10. As you're looking right here, you're going to look at recognizing different representations. Which of the following is an accurate representation for this explicit formula? The first term right here is 15, and the common difference is a negative 7. So I look over here and I see, yes, the first term is 15. So I can add a negative 7 to each one of these, and I should get the same term as the sequence as you can see right here. Now, if you do not have the graphing calculator with you, just add a negative 7 to each previous term. Like 15 plus a negative 7 should give me 8. 8 plus a negative 7 will give me 1, and just keep on working all the way through that, adding a negative 7 to it each time to see if it gives you the same same sequence right here. Now, if you do have a graphing calculator, you can simply type this in, 15 plus parentheses x minus 1 parentheses, and the common difference is a negative 7. Now I'm going to go second and graph. Ooh, okay, let's try this again. Second and graph. Okay, it didn't go. And sometimes when I'm clicking it does not go. Notice that this is the graph of it. Go second and graph. There we go. Now, when I'm looking at this, the first term is 15. The second term is 8. The third term is 1. The fourth term is a negative 6. Fifth term is the negative 13. And this does match all the way across. Now, when I'm looking at this one right here, the first thing that we need to check on, does this have the same common difference right here? This is the explicit formula where you reuse the last term just like we did right here, because 15 plus a negative 7 is 8. 8 plus a negative 7 is 1. This is the recursive formula where I just used it. I just modeled it for you. 1 plus a negative 7 is a negative 6. Negative 6 plus a negative 7 is a negative 13. That is the recursive formula. Now, when I look at this, this does match. Now, the other thing I have to check are these numbers right here. These numbers you have to count backwards in consecutive order. The biggest number must be first, and then the smaller number. So count backwards, and they must be consecutive. If they have the letter N right here and a number right here, that is automatically wrong, because these numbers have to be side by side, consecutive numbers counted backwards. And if you have an N right here, the letter N, then you don't know what number this is, and this could be wrong. So this is a choice right here. Now, When I look at these right here, I can see that my first term is 15, my second term is, and I'm going to bring this over here. And so I'm going to match it up, and I'm going to go ahead and cursor down so that I'm going to start with the first term. First term is 15, second term is 8, third term is 1, fourth term is a -6. That matches. Now I'm going to bring this over here, and I'm going to look at choice D. And then I see that 15 is 8, and when I look at this, and automatically if I stop at 8, 8 is a -34 here, 8 is 1, so that is automatically out. But if I go all the way down to 15, I see 15 is a -83, and 15 here is 8, so that is automatically wrong. So my answer choices are A, B, and C that are correct. Slide number 11. This slide is a match and drag of sequences to their explicit formulas, just like we had the drag that matches the sequences a while ago. And that would be like this one. So slide number 8 and slide number 11 are similar. Slide number 12. This is the recursive formula that I was just talking about. Now, on slide number 12, my first term is 10. My common difference is 8 on the explicit formula, and I have identified that right here. Now, you have to pick out which recursive formula matches. Here's the recursive formula right here. And now, the first thing I see is I have a common difference of 8. So I'm going to check the common difference right here. This is 10, out. This is 10, out. So right here, you have your two choices, these two. Now, once you have, these are the same common difference, and these are two, or one of these two is your correct answer, you're going to look. Make sure that the numbers right here are in descending order. You're counting backwards, and they are consecutive, like 3, 2, 1, 0, count backwards, 10, 9, 8, 7, right here. They cannot be counting up. So these two, this one right here, they do match right here. This one is automatically out because you're counted forward. You want to count backwards. So as I'm looking at this, this is how we came up with the 7 right here. Now, excuse me, you have A sub 8 equals, and this right here, look at this. This is an N and this is an N. These two must match. So I have an 8 here and an 8 here. Now, 8 minus 1, because that's the formula right here, will give you 7. So you have 8, A sub 7 plus 8. This is how we came up with this answer right here. If you had 7 right here, here's another example. This would be 7 and this would be 6 because 7 minus 1 will give you 6. Now, let's go on and look at slide number 13. You've got to find the common difference right here. The first term is 9 and the seventh term is 9. So I put the first term is a -9. So I counted out 1, 2, 3, 4, 5, 6, 7. 7 places across there. I put a -9 in the first place. And in the last place, in the seventh place, I put a 9. Now, we're going to count. How many spaces does it take to get from -9 to the last space of 9? So I'm going to count 1, 2, 3, 4, 5, 6. It takes 6 spaces to go from here all the way to the back. So now, the first thing I'm going to do after that, I'm going to say 9 minus -9, and that is 18. Now, once you get your 18, or whatever the number is right here, you're going to divide this number by the number of spaces it takes to get from front to back. And you see that it is 3. So divide your answer by the number of spaces. And that is your common difference, and that is what you're looking for. Slide number 14. You're going to find the term number given a value. Which term in this sequence is 178? So the first thing I'm going to do is come up right here and subtract. Find your common difference right here. Your common difference when you say 58 minus 48 is 10, 48 minus 38 is 10, 38 minus 28 is 10. 28 minus 18 is 10. So your common difference is 10. Your first term is 18. So now take this information and write it in an explicit formula right here. And then once you have it, you're going to substitute these numbers right here in place of the n right here. And notice I have replaced it. So the first one, and then once you have written it in the explicit formula right here, and you're going to take the 18 plus and put all of this right here all at one time in the calculator, and you see it gives you 158. Same thing right here. Put all of this at one time in the calculator, and it gives you 178. You're going to keep going all the way through here, taking these numbers and putting them in place of the n, and see which one gives you 178. And notice that this second one right here, the 17 does. But remember, you've got to write, once you know that this right here is your explicit, once you have your common difference and your first term, you're going to write this, and I'm going to write it out for you. You're going to say a sub n equals, my first term is 18 plus n minus 1, and my common difference is 10, not 18. Now, once you have that, then you're going to take this, and wherever there's an n in it, you're going to take and substitute each one of these numbers in place of the n right here and see which one gives you an answer of 178. Slide number 15, finding next four terms. You're given the first term, and then you're given the common difference. So when I look at this right here, the first term is a negative 9, which we have it right here, and then you're going to add 12 to each previous term. We're using the recursive formula. So negative 9 plus 12 is 3. 3 plus 12 is 15. 15 plus 12 is 27. And you see that here's the numbers. And then you had to come up 1, 2, 3, and then you'll say 27 plus 12 and come up with 39. Slide number 17. Finding term number given a value. So here's the first term, your common difference, and you have to find the 19th term. So here's the explicit formula right here, and I have color-coded this for you right here. So we're looking for the 19th term, so put a 19 here and a 19 here. The first term is 21. The common difference is 8. Now I'm going to put all of this at one time in the calculator, and your answer is 165. So the 19th term is 165, and that is what I've marked right here. If I were to write this as an order pair, it's going to look like this. The 19th term of this arithmetic sequence is 165. Slide number 17. You're going to describe the patterns and determine the next figure. So the first thing I'm going to do is count your number of spaces or blocks across here, whatever it is. And then you're going to look at this. Well, we had to, when you subtract to find the common difference, you see the common difference is 4. So you're adding 4 more to each previous term right here. And this is the correct answer. You're not subtracting 8 right here and or adding 8. You are adding 4 to each term. This one says 4 times, which means to multiply each term, previous term, by 4. So that would say 5 times 4 would give you 20. Nope, that's not 9 right here. And this one says, well, let's subtract 4. 5 minus 4 will give you 1. No, it's 9. And then if we were to test this out, this says to add 8 more to each previous term. 5 plus 8 is 13. Nope, it's 9. So you're adding 4 to each previous term. Slide number 18. When you're looking at this right here, you have the explicit formula, which they've already worked out for you. You're going to use DSR, distribute, simplify, replace. So as I look at this right here, we have distribute right here. This first step is to distribute. So I'm going to bring down my 9. 10 times n is 10n, and 10 times a negative 1 is a negative 10. Now sometimes the common difference is written in front right here of the parentheses instead of behind. If it is, you still work the same way. You're still distributing. Now you're going to take this right here, and you see this is your first term, second term, third term. So you're going to take your second term right here, and you're going to write it first. Then you're going to take your first term of 9 and add it to your last term, and 9 plus a negative 10 will give me a negative 1. Now, so you have distribute, simplify this. Now you're going to replace it. You see that a sub n right here? You're going to replace the a sub n with f of n or f of x. The thing that you have to remember right here, once you replace, if you replace it, the n right here, this n must also have to match right here. Those two must match. If you, instead of writing an n, you put an x, you must put an x here as well as here. Those two areas must match. Now you're going to write your linear function, which I have, and this is what you're doing on slide number 18. Slide number 19, you're going from explicit to function, linear function. So you're going to do the same thing right here. This time, this is just like slide number 18. Slide number 18 and 19 are exactly the same. The difference is you have to come up with all of this exactly by yourself, the same thing as you do on number 19. However, this time they have it's multiple choice instead of fill in the blank. So you're distributing just like we did before. You're simplifying right here. And so this is your first term, second term, third term. Write your second term first, add your first and your last terms together, and you'll come up with a negative 11, and then replace. So this is the answer right here. Remember, number 18, slide number 18, and slide number 19 are exactly the same. The only difference is one is fill in the blank, and the other is multiple choice. Slide number 20, you're going from explicit to function, linear function. Which function defines this sequence? So now, all you have to do, you see this is your x and this is your y. So you're going to take this right here and substitute 12 all the way down in each one of these right here. Anytime you see an x, you're going to put a 12 in it right here, just like I have. And then put all of this at one time in the calculator, just like you see it right here, and come up with your final answer. And you're looking for a final answer of a negative 157. And so none of these give you an answer of 157 except for this third one right here. But you have to go through every one of these and substitute in whatever they say. This is your x and this is your y. If you wrote it as an ordered pair, it would be 12 and then a negative 157. This is x and then y. They're giving you the x, and just simply substitute it in, plug it in, substitute it in, and see which one gives you a negative 157. Slide number 21, evaluating functions. Now, they are giving you, this is just like what we did on slide number 20. On slide number 21, they're giving you the x this time, and you've got to come up with the y. And so here it is, substitute it in. Anytime you see an x, you're going to substitute in 5.17, which I have right here. Now, put all of this at one time in the calculator, and you'll come up with this big number right here. You're going to have to round off. So I'm going to round off. It's going to be rounded off to 2 decimal places. Now, as I look at this right here, this is 1, 2. This is the number that either stays at a 3 or rounds up to a 4. So is this going to be 0.73 or 0.74? So in order to determine that, I'm going to look to the number directly to the right of it. If this number right here, directly to the right of the number we want to round off, if this number to the right of the number you need to round off is the number 0, 1, 2, 3, or 4. If it's 0, 1, 2, 3, and 4 right here, then this would stay 0.73. But notice this is 8 instead of 0, 1, 2, 3, 4. Now, if the number is 5, talking about this number right here, this third number, if the number is 5, 6, 7, 8, or 9, then that number is rounded up right here. So I'm looking at it, and it is rounded up to 74. Now put these little squiggly lines right here because that means approximately, because we rounded off, and you see this is your answer. Slide number 22. On slide number 22, you're finding the common difference. The first term of a sequence is 10, and the ninth term is a negative 14. So as you're looking at this right here, you're going to have to come up with the common difference. The first step, always subtract. So the difference between the last term that they gave you in the first term. Subtract, and I'm looking at the ninth term. So I drew out 9 spaces across here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you do not have to fill in all those numbers in between. I did though, to make sure that everything worked out. But the first thing you're going to do is subtract these two numbers. So I'm going to say negative 14 minus 10. I'd come up with a negative 24. Now, once you get this number, the second thing you're going to do is divide by this number, divide by the number of hops or steps it takes to go from the first term to the last term. And so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. It takes 8 jumps, 8 hops, 8 steps, whatever you want to say, to go from the first term to the last term. So I'm going to take whatever you get when you subtract and divide it. And I have a negative 24 divided by 8 gives you a negative 3. So my common difference right here is a negative 3. Now, slide number 23. This one right here, notice that you have multiple representations right here of different degrees of working out the explicit formula. Now, here's the explicit formula right here in the white, and I'm going to go back and read this. Darby has agreed to donate $177 to Spring Valley High School for its library. In addition, she will donate $1 for every book a student or child that visits the library reads during the summer. The sequence shown represents the possible outcomes that Darby will be donated for the summer. So the first term right here is 177. If you start the back and subtract 182 minus 184, gives you 1. 182 minus 181 gives you 1. 181 minus 180 gives you 1. 180 minus 179 gives you 1. 179 minus 178 gives you 1. 178 minus 177 gives you 1. So the common difference is 1. The first term is 177. Which representations models this problem situation? Select all. So I'm going to be looking at these right here. I've already written this out in explicit formula using my distributed DSR. Remember DSR, distribute, simplify, replace. So I'm going to use distributive property. I'm going to multiply right here. And here's my first, second, and third terms. So I'm going to write down my first term first. Second term first. And then add my first term and my last term right here together. And it will give you 176. You do not have to write a 1 right here in front of the n. The coefficient is 1, but it's understood to be 1. So, but if you want to write it, it's perfectly fine. Now, so we have distribute. We've simplified. Now we're going to replace the a sub n with f of n and f of x. Remember, you do not have to put a 1 right here, but it's perfectly fine if you write the coefficient of 1 on each one of these. The only thing that you have to remember is if you put an n here, it must be an n here. If you put an x here, you must have an x here. Now, when I look over here, right over here, I'm going to look at the first term and the common difference. And I see the first term is 177, the common difference is 1, but the common difference on this one is a negative 1. So this is automatically out. When I look over here, I see it's 176 minus 1n. Nope, that's a positive 1n right here. So this one is out. When I look at this, we had 176, not 177 plus 1n. Now, when I look at this, I see that this right here matches when I matches this right here. And remember, the common difference can be written in front of the set of parentheses like they have it right here, and it's perfectly fine. So this is when they set up the the explicit formula. Now, when they have worked it all the way out, you see that this is 176 plus 1x instead of x plus 176. It's perfectly fine because this is community property of addition. 1 plus 3 equals 3 plus 1, whichever way you say it. Now, when I look at this right here, we have, when we simplified, it's 176, not 177. So this one is automatically out. 24, you're going to evaluate given equations for correctness. Adley and Heidi were asked to find an explicit formula for this sequence. So she started at the back. -8 minus 0 is a -8. 0 minus 8 is a -8. 8 minus 16 is a -8. Then they identify the first term. Adley wrote this right here. And then Heidi said, no, this is the formula. Well, who's right? So the first thing I did was I wrote the explicit formula right here. Identify the first term and the common difference. And then I substituted all of this in its place right here. Distribute, simplify, replace, or we not replace it, but distribute. Now, -8 times n is a -8n. -8 times a -1 is a +8. Bring down your 16. Write your second term first, and then add your first and your last terms together, and you get 24. Now, as you can see right here, both girls are correct. Their problems are in just different stages of working it out. Adley set up the problem using the explicit formula right here. She just did not simplify it. She just left it as an explicit formula. So this right here is correct. Now, Adley, or Heidi, said, well, she went ahead and worked it out. So, as you can see right here, 24 plus a -8n is the same thing as saying -8n plus 24. So both girls are correct. They're just different stages of working it out. And now, these are all 24 problems that match your test. Now, make sure that you study this and are able to work every single one of these problems, and then you will go back and take your test.